Hello all, I'm Mithun and welcome back to a brand new video. So in this video, we are going to look into what I would say is software sometimes becomes very much boring, okay, and you need to spark that curiosity and some of these concepts which help you to spark the software curiosity is what we are going to look into this video. Okay, again, so these are the terms which you will see a lot in real life. Okay, you would see encoding like base 64 encoding, UTF-8 encoding, and then whenever you enter a password, you would always wonder that how are these companies securing my password or securely storing my password. So that's where hashing comes into picture. And then whenever you open WhatsApp, it says that end-to-end encrypted. What does encryption actually mean, and how it ensures security? And yeah, so if these are the techniques which are ensuring security, then why do we have different ways of doing it? What are its advantages? What are its limitations? And there is a lot of a buzz around quantum computers, supercomputers, okay, especially the quantum computers, where you hear telling that if quantum computer comes into picture, then all of these encryptions will fail. How will they fail? Okay, so all of these creative juice questions is what we are going to answer in this particular video. I have just selected three of these most confusing things but yet interesting concepts for today. But yeah, so if you want more of these type of videos, give this video a thumbs up and a channel a sub, so I would know that you are liking this type of content and I can bring more. Okay, again, so let's get started. First, let's start with the simple encoding ones. Okay, encoding. So again, these three are very much confused and interchangeably used. Okay, whenever I say encoded, someone will be like, oh, encrypted, hashed are same. No, they are not same. So to demonstrate this, let me give a simple example. Okay, so let me go here, and if you see on my on my desktop, I have a file sqlcommands.pdf. If you see, in this file name, I have some empty spaces. I have some special characters which are not usually used. Okay, it's restricted. Okay, people tell don't use spaces in your file names and all, right? Let me open this with Chrome. Okay, see, as soon as I open this with Chrome, can you see the difference in the URL? Okay, here it gives me the file path, great desktop, and then it should have given SQL space question mark commands.pdf, but it's not giving. It's giving me the percentage 20 instead of the space. It's giving me percentage 3f instead of question mark. What does this signify? Okay, so that's what encoding says. Encoding says is that encoding is not change of any information. It's just a representation of information in a different format. Why? To access the resources better. Okay, like let's take this example. So in this example, URLs, okay, so we call this as a URL, right? URLs are restricted to use specific characters. Okay, so it restricts the use of empty spaces, question mark. It says that, hey, don't use this. Okay, so this is the rule of the URLs. They are restricted. So whenever you have this empty spaces, question mark, then you need to represent it in a different way so that the information can be accessed. So that's what encoding simply means. Again, a simpler example would be CSS colors. Whenever you want to add a color, there are different formats like hex code, RGB, RGBA. They are the different representation of the same thing itself. Okay, so that's what encoding is. Next, whenever we are loading assets, media files, okay, like let's say image on our website, one way is through URLs. I can just attach the URL, but like let's say whenever the image is very much small and we don't want this over the network, there will be some attacks happening, or the image form would be changed. Okay, that's possible. Okay, over a network it can be done. So at that time, what we do is that we directly load the base 64 of the image. Okay, so again, you will just have these terms, you will explore that later. But yeah, so that's where what we are doing is that we are taking an image, we are converting it to a more readable form or more machine understandable form of base 64. So that's what encoding is. Encoding is simply representing the data in a different format according to the requirement. Okay, so for the easier access. So this is encoding. So that's why whenever you look into your URLs, question mark plus, it will be converted into percentage 20, 30 f, something like that. So these is where browser is doing its job so that the URLs are in this specific format. So that's what encoding is. Very simple. And then, is encoding ensures any security? No, encoding doesn't ensures any security. It is not nothing related to security at all. It's just a different format of representing the data. So no security comes into picture, and it's reversible. Okay, like let's say you have this. Oh, if you are good at encoding, if you have that in your mind, you can reverse it straight away. Or there are a lot of encoders, decoders, because this is universal. There is no specific rule we are adding. These are universal rules, so it's very easy to um, decode as well, or else it's reversible. Okay, so you guys know the use cases where it is using. Great. Next comes the very important part, hashing. Okay, so this is where a lot of things gets changed. Imagine you are filling a login for sign up form, you entered your email and your password. Okay, does companies store your password? No, companies will never store your password in plain text. What they will do is that they will hash it, okay, and store the hash. Now, Mithun, what is hashing? Hashing is simply a process of converting a text, okay, any of the text into a fixed length hash, okay. So through mathematical formula. So if you have, like, let's say Mithun is the text. What we do is that we run a mathematical algorithm and we give a fixed length hash. Okay, hash will be something like this. Okay, some not so much user readable text. This is the hash. Always remember that hash will be unique, okay, and then it will be of fixed length. Okay, like let's say if Mithun has this much length of hash, if there is only m, even then it will be fixed length but unique. So you should know that hashing is a process where we run a mathematical function, like let's say f of x, we are running a mathematical function on the data and we are getting a hash. The properties of hash is it's unique. Okay, for unique inputs it is unique, and then it is of fixed length. Great, so this is hashing. Now, Mithun, how does it provide security? It provides security because it's irreversible. You can once hash, like let's say if I hash the text Mithun, I get the hash. It's irreversible. You cannot get the text back. So no matter companies have your hash, it is irreversible. It's like fingerprint. You can store fingerprint, you can compare fingerprints, but you cannot revert a fingerprint. I will give you the fingerprint, give me the data of my fingerprint. No, it doesn't work. So same way, whenever you companies store your password, they store the hash. So whenever you sign up, they can compare it, telling that, hey, are these two same? But they cannot reverse it. Okay, so that's where the significance of hashing comes into picture, and normal computers cannot break this hash. Okay, so the concept is built so that it is irreversible. So there are a lot of SHA-256 hashing, bcrypt hashing, there are a lot of hashings. So encoding doesn't provide any security, it's just a different representation. Hashing provides security by giving you a fixed length unique hash which is irreversible in nature. Okay, great. So this is hashing. So the main selling point of hashing is that it's irreversible. So that's the whole point of it. Great. Next, let's look into again a very important ones, but exciting ones of all to learn, that is encryption. Encryption. Okay, so now you got to know about hashing. Okay, the problem with hashing is that it's irreversible. Okay, I cannot reverse it. But there comes some situations that I want to reverse it. Okay, I will convert into a different form and I want to reverse it, but only specific people can reverse it, like an end-to-end encryption of a WhatsApp. Like if I send a DM to you, only we both should be able to see it. No one in middle in the network should be able to see it. Okay, so how does this encryption comes into picture? Okay, so let me first take you through an example of where this all started. Okay, so we have this famous method of Caesar cipher method. Okay, so Caesar cipher method is a very simple, it's not used today, but it's the basic example you can take it to understand encryption. It's like shifting characters with specific times. Okay, like let's say shifting characters for 3 times. This we call it as a key. Only people who know this can decrypt it. Okay, like let's say I have a message called as hello, HELLO. Now what cipher method says is that shift this character to 3 times. Like if you have uh, HIJK, add K, 3 characters plus 3 characters. E, okay, EFGH, okay, 3 characters. EFGH, add H, okay, LMNO. What is the next third character of it? Okay, again O, PQR. Okay, so now instead of transmitting hello, we'll transmit KHOR, KHOR. And then the person who knows this key, telling that, hey, so this is ahead of 3 characters, they will decrypt, come back 3 characters, and then get the original text hello. You understood? This is what simply encryption is. So encryption is all about having some key, okay, and modifying the content. Okay, again, so this is very basic. Okay, so this is not used in 2025. We have complex mathematical equations which a regular machine can solve. Now with the rise of quantum computers, people are scared, okay, that quantum computers are so much powerful, they can do so much calculations per millisecond, billions of calculations per millisecond. These encryptions can break. Okay, so that's the fear of quantum computing. But yeah, in 2025 regular computers cannot break this encryption, okay, in brute force. But there are chances of breaking it, so that's why machines get hacked. Okay, but easily it's not able to crack it. So this is what encryption is. Encryption is a way of transmitting the text in a modified form. Only the person who has the key can be able to reverse it. Again, it's reversible, but only with key. So whenever I say end-to-end encryption in WhatsApp, the encryption key is in my phone and on your phone. It's not on the network. Okay, but when I transmit, I say that, hey, so this key is also allowed. Okay, so you get the key as well, and then you decrypt the message. So that's why WhatsApp is secure, but it's reversible and it's hackable. Okay, so these are not cannot be done by brute force approaches, but complex machines and algorithms can crack it. So this is the whole of encoding, hashing, and encryption. It's a lot exciting, right? Encoding is just a representation. Okay, it is not secure, no security promises. Hashing, even today, passwords, even your banking systems use hashing concepts. Okay, they have a layer of OTP, two-factor authentication, but underlying hash will be there. Okay, where all of your information will be converted into a fixed length hash. Okay, and it is irreversible. Whenever you want it to be reversible, you use the concept of encryption with keys. Okay, so that is where a lot of things comes into picture. Again, one of the interesting use case I remember about hashing is that what happens is that whenever a file is transmitted, like let's say there is a file, whenever a file is transmitted from one place to another, one machine to another, a file is transmitted. So how to check if this file is corrupted or not? So what people usually do is that before sending the file, they will hash it. Okay, and after sending the file, they will hash it. If you are using the same hash, okay, then it should be of same length. Okay, so that's where people check if the file is corrupted or not. On the server and the client, if the same hash exists, the length of hash is same, that means the file is not corrupted. If the length is different, means a different algorithm is used, different key is used, different salt is used, so which says that, hey, this is modified. Okay, so there are a lot of ways. It's not just directly onto the security, but a lot of places, interesting use cases where these 3 techniques are used. Okay, just try out and look into your applications where you can use this, explore more. These are the concepts which makes software a lot exciting and real life. That's it for this video, and I will catch you up in the next one. Thank you.